In the previous video, we looked at some experimental data to try to determine what the rate of a particular reaction is. And sometimes this stuff can get a little bit confusing, so we need to come up with something called a rate law in order to simply express how the rate of a particular reaction changes with time. So a simple rate law expresses how the rate depends on the concentration. And if we have a generic chemical equation where we give A giving B plus C, the rate is going to be proportional to the concentration of A. And we have a couple ways that we could write rates. A is a reactant, so that means the concentration is going to decrease. So we can say the rate is going to be equal to the negative change in concentration of A with respect to time. And we also know that the rate is proportional to the concentration of A. Okay, so anytime we see a proportion, we can add something like a constant to get a true rate expression. So our rate expression, we can say, is going to be equal to K times the concentration of A to the X power. Okay? This K right here is something we're going to refer to as a rate constant. And X right here refers to the order of the reaction with respect to A. And if there were more than one reactant, we would have a longer expression, and we're going to look at a couple of examples of this. But this is how we would write a rate law, and we write the rate law with respect to the reactants. Okay, so for example, if we had a particular reaction where I took nitrogen gas and added 3 moles of hydrogen gas, we could produce 2 moles of ammonia. Okay, and this is a very important industrial reaction to produce ammonia. If we wanted to write the rate law, we can say the rate is going to be equal to K, which is the rate constant, times the concentration of the reactants, in this case nitrogen to the X power and hydrogen to the Y power. This would be our template that we would write for our rate law. One thing that I want to highly emphasize, okay, X and Y are the order of the reaction with respect to N2 and H2. Okay? The order does not depend on stoichiometry. And if we wanted to calculate this, we need to know something about a particular chemical reaction. We need experimental data to determine what the order of this rate law will be. Okay, so whenever you calculate these, resist the temptation to use the coefficients from the balanced chemical equation. We need to use experimental data. So experimental data is needed to determine the order. And in this case, the order would be X and Y. Okay, and we're going to go through, I know this is kind of abstract here, but we're going to go through a couple examples of a simple reaction, then a little bit more complicated reaction of how to determine the order of the reaction and the overall rate law.